Hello, and welcome to the Science Pulse. Above the northern horizon lies a faint blur of light, the Andromeda Galaxy. To the naked eye, it seems delicate, almost ghost-like, yet it carries a secret written in the fabric of time. It is moving toward us. In 4 billion years, Andromeda will collide with the Milky Way, reshaping the sky and birthing a new galaxy. Tonight, we explore this coming cosmic storm, what astronomers have discovered, what fate awaits our solar system, and what it means for the impermanence of the heavens. Before we begin, share where you're watching from in the comments. Andromeda, shadows across a coming collision. High above the northern horizon, a faint blur drifts in the velvet dark, so dim that only the clearest skies reveal it to the naked eye. To most, it appears as little more than a ghost of light, a smudge among the stars. Yet that ghost is Andromeda, the nearest great spiral galaxy beyond our own, and its presence carries a secret written across the fabric of time. For Andromeda is not fixed in the heavens, it is moving. Across the gulf of 2.5 million light-years, it is falling toward us, the Milky Way, in a silent approach so vast, so inevitable, that nothing in creation can prevent it. Astronomers have measured its trajectory with exquisite precision, and the verdict is certain. In 4 billion years, Andromeda and the Milky Way will collide. It will be a collision of giants, each holding hundreds of billions of stars, each wrapped in invisible halos of dark matter. They will not strike like solid objects, but pass through and around one another, tearing tides of stars into arcs of light, igniting new regions of star birth, and scattering whole solar systems into unfamiliar skies. In time, the two spirals will merge, giving rise to a single colossal galaxy, a luminous graveyard and a newborn in one. We live on the edge of this future. Though human lifespans are brief, the destiny of our galaxy is already written, etched into the slow drift of starlight overhead. And every night, as Andromeda rises, we are reminded the cosmos is not static, but alive. A universe where even galaxies are destined to collide. Discovery phase, the awakening of Andromeda. In the quiet stillness of ancient nights, long before telescopes or science, the Andromeda Galaxy appeared only as a whisper in the heavens. To most eyes, it was invisible, drowned in the glow of the Milky Way. Yet under the clearest skies, far from firelight or city smoke, a faint smudge could be seen, a patch of ghostly haze, subtle and fleeting. The ancients gave it no name beyond myth. To them, it was a fragment of cloud, a breath of light caught between stars. Few could have imagined that this pale apparition was another island of creation, vast beyond comprehension, and destined one day to collide with our own. The first recorded glimpse, the earliest known written description, comes from the Persian astronomer Abd al-Rahman al-Sufi in the 10th century. In his book of fixed stars, he noted the little cloud in the constellation of Andromeda, a faint nebulous object just visible to the naked eye. He could not know what it was, only that it was different, neither star nor planet, a soft glow adrift in darkness. His words stand as the first step in a journey that would take nearly a millennium to unravel. Through the Middle Ages, the smudge was catalogued but not explained. In the 17th century, Simon Marius described it through one of the first telescopes, noting a diffuse glow but no detail. It would take centuries more for humanity to pierce its veil. The Age of Nebulae. By the 18th and 19th centuries, astronomers had begun to catalog hundreds of such nebulae, diffuse clouds scattered across the sky. The great French comet hunter, Charles Messier, included Andromeda as entry M31 in his catalog of non-cometary objects, warning other observers not to mistake it for a comet. To him, it was only a curiosity, a blur to be marked and moved past. But questions lingered. Were these nebulae merely gas clouds within the Milky Way? Or were they something else entirely? The debate raged quietly for decades, awaiting the power of better instruments to decide. The Great Debate. By the early 20th century, telescopes had grown powerful enough to reveal structure within Andromeda. Spiral arms emerged faintly from the haze, suggesting it was not a formless cloud, but a coherent system. Yet the scale was unknown. Was Andromeda a small spiral of stars orbiting within our Milky Way? Or was it something larger, farther, grander, a universe of its own? This question came to a head in 1920 at the Smithsonian's National Academy of Sciences in Washington, D.C., in what became known as the Great Debate. Two leading astronomers, Harlow Shapley and Heber Curtis, stood opposed. Shapley argued that the Milky Way was the entirety of the universe, vast and containing all. Andromeda, he insisted, was simply a nearby nebula within it. Curtis countered that Andromeda and other spirals were island universes, galaxies in their own right, each immense and separate. The debate ended without resolution. The truth would be revealed soon after. Hubble's revelation. In the 1920s, Edwin Hubble turned the 100-inch Hooker telescope at Mount Wilson Observatory toward Andromeda. Using variable stars known as Cepheids, cosmic lighthouses with predictable brightness cycles, he calculated its distance. The result was staggering. Andromeda lay far beyond the Milky Way, some 2.5 million light-years away. The universe had cracked open. What was once a nebula became a galaxy, rivaling and surpassing our own. Suddenly, the Milky Way was no longer the totality of creation, but one island in an archipelago of billions. The forgotten smudge of light had shattered humanity's vision of the cosmos. Andromeda, once a little cloud, was revealed as a spiral of hundreds of billions of stars, a colossal city of suns drifting across the void. The shock of motion. Even more unsettling than its size was its trajectory. By measuring the Doppler shift of its light, astronomers discovered that Andromeda was not receding like most galaxies in the expanding universe. It was approaching. Its light was blue-shifted, compressed by motion toward us. The smudge in the sky was not a static presence, but a traveler, one on a collision course with the Milky Way. This revelation transformed Andromeda from a symbol of distant wonder into a harbinger of destiny. For the first time, humanity glimpsed a cosmic future written in motion. Two galaxies bound together, destined to merge in a collision billions of years hence. The broader awakening. Andromeda's discovery was more than astronomical. It was existential. Until Hubble's revelation, the Milky Way had been the universe. Afterward, it was only one of many, each a realm of stars with its own history and fate, the center of this awakening. For Kepler, Galileo, and Newton, the cosmos was the solar system. For Hubble, it was galaxies. And in the smudge of Andromeda, the greatest shock was revealed. We are not alone in space, nor are we isolated. The Milky Way itself is part of a larger story, one shaped by attraction, collision, and change. The ghost in the night sky. Even now, Andromeda is visible as a faint patch to those who know where to look. Every photon reaching us has traveled millions of years, a message sent before humanity existed. To the ancients, it was mystery. To Al-Sufi, it was a cloud. To Messier, a nebula. To Hubble, a galaxy. And to us, it is a mirror of destiny, a reminder that the future of the Milky Way is bound to this ghostly light. The discovery phase of Andromeda is more than a story of telescopes and measurements. It is a parable of vision itself, how a smudge in the sky can grow into the revelation of an entire universe, and how within that universe we find our own future written. Scientific shock, a collision written in the stars. For centuries, the heavens were thought of as eternal, unchanging, a backdrop against which the fragile drama of human history played out. The stars were fixed, the galaxies immutable, the sky a stable dome above Earth. But the revelation of Andromeda's motion shattered this ancient certainty. The faint blur in the constellation of the chained princess was not drifting aimlessly in space. It was racing toward us, pulled by a force that bound even galaxies together. The shock of this discovery was profound. It revealed a universe not of permanence, but of violent galaxies. Vast systems of hundreds of billions of stars are transient, colliding, merging, and reshaping in endless cycles. The expanding universe, with one exception. By the 1920s, Edwin Hubble had shown that the universe was expanding. Most galaxies revealed their recession through redshift. Their light stretched as they moved away, like sirens fading into the distance. The cosmos was not static but swelling, every galaxy rushing from every other in a grand cosmic exhalation. And yet, among the retreating hosts, Andromeda stood alone. Its light was blue-shifted, compressed as it sped toward us. Against the background of universal expansion, it was the one galaxy drawing closer. This was not a mistake of measurement, nor a fleeting anomaly. It was a clear message written in starlight. Our galaxy and Andromeda were locked in a gravitational embrace. The timeline of catastrophe calculations revealed the inevitability. At a distance of 2.5 million light-years, Andromeda was approaching at over 100 kilometers per second. Slowly, silently, it was falling toward us. The timescale dwarfed human comprehension. 4 to 5 billion years until the collision. But in cosmic terms, it was tomorrow. This realization carried a strange weight. Humanity, so concerned with centuries and nations, was suddenly confronted with a future where even the Milky Way would perish. The constellations we know, Orion, Cassiopeia, Ursa Major, are fleeting, destined to dissolve as the stars themselves are scattered and rearranged in the coming collision. The sky will change. What will this collision look like? Simulations reveal a haunting vision. First, Andromeda will grow larger in the night sky, a spiral swelling until it dwarfs the Milky Way. Then the galaxies will pass through one another, their stars rarely colliding, but their structures tearing apart. Long streams of stars will be drawn into tidal tails, arcs of light stretching across the heavens. Gas clouds will crash, triggering waves of star birth that ignite new suns in spectacular bursts. After billions of years, the chaos will settle into a single, massive elliptical galaxy, a fusion of the Milky Way and Andromeda, sometimes called Milkomeda. The night sky will glow with unfamiliar constellations, the legacy of a collision written in every horizon. For any life that survives, the sky will be unrecognizable. For humanity, long extinct by then, it is a reminder that the sky we cherish is not eternal. Even the stars above are fragile, shifting, destined for transformation. The violence of galaxies. Andromeda's fate with the Milky Way is not unusual. Across the universe, galaxies are born from collision. The Hubble Space Telescope has revealed countless galactic mergers, spirals twisted into arcs, collisions scattering stars like sparks from a fire, cosmic graveyards where two galaxies have become one. Our own galaxy carries scars of such encounters. Streams of stars arc around the Milky Way, remnants of smaller galaxies consumed long ago. The Sagittarius dwarf galaxy, torn and stretched, is still being absorbed. The cosmic dance is relentless, and Andromeda is simply the next great partner. The shock of this realization cannot be overstated. The sky itself, once the symbol of eternity, is revealed as impermanent. Galaxies collide, stars scatter. The very fabric of the heavens is in motion. The terror and the wonder. To early astronomers, the notion of galaxies colliding was unthinkable. They seemed too vast, too eternal, too divine to be destroyed. Yet modern science shows a cosmos where destruction and creation are inseparable. Collisions tear galaxies apart, but they also ignite new worlds, new suns, new possibilities for life. This duality, terror and wonder, chaos and creation, is the essence of Andromeda's coming collision. It is not an apocalypse in the human sense, but a transformation, one that reveals the true nature of the cosmos. Nothing is fixed, nothing is permanent, everything changes. The existential shock. Perhaps the greatest shock lies not in astronomy, but in philosophy. The knowledge that our galaxy's future is already written confronts us with the fragility of human existence. Civilizations rise and fall in thousands of years. Species evolve and vanish in millions. Yet galaxies dance in billions. Humanity's story is a flicker within a play that has been unfolding for eons and will continue long after we are gone. To know that Andromeda is approaching is to be reminded of our place in the hierarchy of time. We are not the masters of the cosmos, but passengers within it, inhabitants of a galaxy whose fate is sealed, bound by gravity to another. The discovery of Andromeda's motion was more than a scientific revelation. It was a profound shock to the human spirit. It told us that the sky is not eternal, that even galaxies are mortal, and that we are part of a drama far larger than ourselves. The collision is distant, yet its shadow stretches across us even now, a reminder that the universe is alive with change, and that permanence is an illusion. Deeper investigation, measuring the fall of giants. The realization that Andromeda is approaching the Milky Way raised profound questions. How fast is it moving? When exactly will it arrive? What will the collision look like? And what will become of our solar system? To answer these questions, astronomers turn to the most precise instruments of their age, measuring light, motion, and gravity with exquisite care. Each discovery deepened the picture, revealing a future both terrifying and wondrous. Two galaxies bound by gravity, drawn together in an unavoidable embrace. The Doppler shift, first signs of approach. The first clue came from the Doppler effect, the same principle that shifts the pitch of a passing siren. Light, too, is stretched or compressed by motion. If a galaxy moves away, its light reddens, stretched into longer wavelengths. If it approaches, the light is compressed into shorter, bluer wavelengths. Its spectrum was blue shifted. Unlike most galaxies, in the expanding universe, which fled outward into the void, Andromeda was racing toward us. At first, the speed was estimated at over 300 kilometers per second. later refined to around 110. Across 2.5 million light-years, this approach is relentless. The collision is not speculation, but certainty. Proper motion, measuring the sideways drift. Yet speed alone was not enough. A head-on collision is different from a glancing pass, and the difference lies in sideways motion, what astronomers call proper motion. For decades, this was the missing piece. Telescopes could measure Andromeda's approach, but not its sideways drift across the sky. Was it aimed directly at us, or would it slip past in a near miss? The answer came with the Hubble Space Telescope. By comparing images taken years apart, astronomers tracked tiny shifts in Andromeda's stars, movements so small they spanned mere micro-arcseconds. The conclusion was clear. Andromeda is not sliding past. It is falling almost directly toward the Milky Way. More recently, the Gaia mission has confirmed these measurements with extraordinary precision, mapping the motions of stars in both galaxies. The verdict stands. The two spirals are locked in a trajectory of collision. Simulations of the collision. With motion measured, astronomers turn to computers to simulate the future. These models, built on the laws of gravity and the structure of dark matter halos, reveal a breathtaking vision of cosmic transformation. In roughly 4 billion years, Andromeda will loom large in the night sky, a spiral of stars rivaling the moon in size. Within 1 billion years more, the galaxies will pass through each other, their shapes twisted into long tidal tails of stars. After several passes, crashing together, separating, then falling back again, the two will finally merge into a single, giant elliptical galaxy. This new system, sometimes called Milkomeda, will blaze with star formation at first, then gradually fade as its gas is consumed. The familiar spiral arms of both galaxies will vanish, replaced by a smooth, spheroidal glow. What was once two will become one, a luminous relic adrift in an ever-expanding void. The role of dark matter. The collision is not only between visible stars, but between invisible halos of dark matter that surround each galaxy. These halos, vast and overlapping, are the true engines of the merger. As they collide, they slow the galaxies, absorbing momentum and ensuring that the two spirals cannot simply pass by. Dark matter is the silent architect of the collision, binding Andromeda and the Milky Way inescapably together. Without it, the galaxies might have slipped past, forever separate. With it, the merger is guaranteed. The fate of the solar system. Perhaps the most haunting question is this: what will become of Earth and the solar system when the collision begins? Simulations suggest that the odds of our sun directly colliding with another star are vanishingly small. Stars are so far apart, separated by light years of emptiness, that even in a galactic collision, they pass like ships in a vast ocean. But the sun's orbit will not remain unchanged. Gravity will hurl stars into new trajectories, and our solar system may be flung outward into the galaxy's halo or drawn toward its center. The sky from Earth, if Earth still exists in habitable form, will change beyond recognition. New constellations will form, great arcs of stars stretching across the heavens, and Andromeda's stars will blaze in the night as they intermingle with our own. By then, however, Earth itself may not survive as a cradle of life. In 5 billion years, the sun will swell into a red giant, engulfing Mercury and Venus, and perhaps Earth as well. If humanity endures, it will not be here. The galactic collision is a story for descendants far beyond us, or for civilizations yet unborn. Galaxies in context. Andromeda's approach is not unique. Across the universe, collisions shape the lives of galaxies. Ellipticals are often the result of mergers, their smooth shapes evidence of past violence. Spiral galaxies, too, bear scars. Warped disks, star streams, and asymmetrical arms, all signatures of past encounters. Even Andromeda itself shows such scars. Its halo contains faint arcs of stars, remnants of smaller galaxies torn apart. The Milky Way, too, has consumed many companions, their stars now spread in great rivers across our sky. Collisions are not anomalies, but the heartbeat of cosmic evolution, the scale of destiny. To contemplate this future is to stretch the human imagination across scales it was never built to hold. The fall of Andromeda is written in billions of years, yet it is already unfolding. With every moment, the distance closes. With every night, the faint smudge in the sky draws imperceptibly nearer. It is a reminder that time itself is different in the cosmos. For humanity, a century is long. For galaxies, a billion years is brief. The collision of Milky Way and Andromeda is not a distant dream, but an imminent event in cosmic terms. A future as certain as tomorrow's dawn. The deeper astronomers looked, the clearer the vision became. Andromeda is not a ghost drifting across the night sky. It is a shadow of our future, the reflection of a collision already begun. The discovery was not simply of a galaxy, but of destiny, a reminder that nothing, not even galaxies, endures unchanged. Escalation. The mystery deepens. The realization that Andromeda is hurtling toward us was shocking enough. But as astronomers looked deeper, the mystery of galactic collisions became stranger still. Andromeda itself is scarred by past encounters. The Milky Way, too, bears the remnants of galaxies already devoured. What at first seemed an isolated future catastrophe is, in truth, part of a much larger story. A cosmic cycle written into the very architecture of the universe. Andromeda's haunted halo. When astronomers began mapping the faint outskirts of Andromeda, they discovered something eerie. Vast streams of stars looping around it like ghostly rivers of light. These are the remains of smaller galaxies, shredded and absorbed into Andromeda's gravitational field. One such stream, the giant stellar stream, is the torn remnant of a galaxy that collided with Andromeda billions of years ago. The halo is filled with such echoes, stellar arcs, faint clusters, disrupted satellites. Andromeda is not pristine, but a graveyard of galaxies. Its shape, its mass, its very structure is the product of ancient collisions. The approaching merger with the Milky Way will not be its first. It will simply be the next chapter. The Milky Way's own scars. Our own galaxy carries similar wounds. It is currently being devoured, its stars stretched into long tidal streams wrapping around the Milky Way. Other streams trace the remnants of collisions long past, skeletal outlines of galaxies that no longer exist. In 2018, data from the Gaia mission revealed an extraordinary discovery. Billions of years ago, the Milky Way experienced a titanic merger with a galaxy now called Gaia Enceladus, or the Gaia sausage. The stars of this ancient invader still move in distinct orbits, their trajectories fossil records of a collision that reshaped our galaxy. We are not witnessing. The Milky Way and Andromeda, now on course for collision, are themselves survivors of countless past encounters. The local group, a family bound by gravity. The Milky Way and Andromeda do not exist in isolation. Together, they dominate a small collection of galaxies called the local group. a cluster of more than 50 members bound together by gravity. Among them is the Triangulum Galaxy, the local group's third largest member. Triangulum orbits near Andromeda, and some simulations suggest it may join the coming collision, plunging into the chaos of the merger. Around them swarm dozens of dwarf galaxies, satellites pulled between their giant hosts, many destined to be torn apart. The local group is a microcosm of cosmic evolution. Galaxies orbiting, colliding, merging, their fates intertwined. Andromeda's approach to the Milky Way is not an anomaly, but the natural consequence of this gravitational family. The web that binds zoom out further, and the inevitability becomes clear. Galaxies are not scattered randomly, but connected by the cosmic web, vast filaments of dark matter stretching across the universe. Within this web, gravity pulls galaxies into groups and clusters. Collisions are not accidents. They are the architecture of the cosmos. The Milky Way and Andromeda are caught in this web, slowly drifting together over billions of years. Their halos of dark matter overlap, binding them long before their stars touch. In this sense, the collision is already underway. The galaxies have not yet met, but their invisible scaffolding has entwined them. The mystery of timing. Simulations show that the first close pass will occur in about 4 billion years. But the exact timing remains uncertain, dependent on the structure of the galaxy's halos and the gravitational tug of satellites like Triangulum. Will the merger be swift, collapsing the galaxies into one in a few billion years, or will it be drawn out, with multiple passes before the final fusion? Astronomers refine their models with each new observation. Gaia's precision measurements of stellar motions in Andromeda are narrowing the possibilities. But even with the best data, the future is not entirely predictable. Gravity ensures the collision, but the details remain hidden in chaos. Collisions as creators. For all their violence, galactic mergers are not purely destructive. They ignite creation. When gas clouds collide, they collapse into new stars, triggering bursts of star formation. The Milky Way-Andromeda merger will likely ignite tens of billions of new suns, seeding the skies of the future with brilliance. Supermassive black holes, lurking at the centers of both galaxies, will spiral toward each other, eventually merging in a titanic release of gravitational waves that will ripple across the universe. The resulting black hole will dwarf either progenitor, anchoring the heart of the new galaxy. The destruction of structure, spirals dissolving, stars scattered, will give birth to something new. The cosmos thrives on such transformations, the shadow over the future. And yet, the deeper the investigation, the more haunting the picture becomes. Even as the new galaxy forms, the wider universe will slip away. Dark energy, the mysterious force accelerating cosmic expansion, will drive distant galaxies beyond visibility. When Milkomeda finally takes shape, its stars glowing in unfamiliar constellations, it will exist in a lonelier universe, a solitary island in an ever-darkening sea. Future civilizations, if any exist, may never know that other galaxies once filled the night. They may see only their own, unaware of the vast cosmos beyond. In this sense, the Milky Way-Andromeda collision is not only an event of creation and destruction, but a narrowing of vision, a future where the universe itself appears smaller. The deeper escalation. The mystery is no longer only about Andromeda's approach. It is about inevitability. Galaxies are not static. They are participants in a grand cycle of collisions, mergers, and rebirths. The Milky Way and Andromeda are not exceptions, but the rule. The deeper the investigation, the clearer it becomes. Nothing in the cosmos is permanent. The night sky, which for millennia seemed eternal, is in motion. Constellations will vanish, spirals will collapse, galaxies will fuse, and even the universe itself may one day fade. Andromeda's shadow is not only across the coming collision, but across our understanding of time, permanence, and existence itself. The mystery has deepened. What once seemed a distant blur is revealed as destiny. What once seemed static is revealed as motion. And what once seemed eternal is revealed as fleeting. The smudge in the night sky is no longer only Andromeda. It is a reminder that the universe is a place of ceaseless change, where even galaxies live, collide, and die. Theories and speculations, the birth of Milkomeda. The Milky Way and Andromeda are not simply drifting toward one another. They are writing the next chapter of galactic evolution. Their approach, their collision, and their ultimate union will give rise to something new. A galaxy unlike either parent, vast and luminous, a monument to cosmic transformation. Astronomers have given it a name, both playful and profound, Milkomeda. And while the broad strokes of this destiny are known, the details open the door to speculation, scientific, philosophical, and even existential. What will the new galaxy look like? Simulations suggest that when the Milky Way and Andromeda finally merge, their spiral arms will dissolve, flung outward in luminous streams. The elegant disks of both galaxies will be shredded, their shapes lost in tidal chaos. Over billions of years, the chaos will settle into a spheroid, a giant elliptical galaxy, smooth and round, glowing with the combined light of trillions of stars. The night sky, for any surviving worlds, will be transformed. Instead of a thin river of stars like today's Milky Way, the heavens will blaze with an immense, concentrated glow. Andromeda's stars will no longer appear as a faint blur, but will mingle with our own, filling the sky with unfamiliar constellations. The galaxy will be larger, more massive, and brighter than either parent. But it will also be older. Its raw materials of gas and dust consumed in the burst of star formation that accompanies the collision. Milkomeda will shine brilliantly for a time, then slowly fade into the silence of aging stars. The fate of the solar system. The most haunting speculation concerns our own solar system. The probability of the Sun colliding directly with another star is nearly zero. Its orbit will not escape disturbance. Gravity, in its relentless pull, will reshape the trajectories of countless stars. Some will be cast into the galaxy's outer halo. Others will fall toward the center. The Sun, too, may be thrown into a new orbit, perhaps wandering farther from the galactic core, perhaps plunging closer. Earth, if it still exists, may see its sky filled with stars from Andromeda, dazzling arcs of light stretching across the horizon. But here lies the nation. In about 5 billion years, the Sun will exhaust its hydrogen fuel and swell into a red giant, likely consuming Mercury and Venus, and perhaps Earth as well. If humanity or its descendants endure to see the merging galaxies, it will be from another world, under another sky. Black holes in collision. At the centers of both the Milky Way and Andromeda lurk supermassive black holes, each millions of times the mass of the Sun. As the galaxies merge, these titans will spiral toward each other, dragging space and time with them. Eventually, they will collide, releasing an unimaginable torrent of gravitational waves that will ripple across the cosmos. The merged black hole will be even larger, anchoring the heart of Milkomeda. Around it, stars will orbit in violent dances, while jets of energy may blaze forth as gas falls into the abyss. To any future civilization, the collision of these black holes would mark the climax of the galactic merger, a silent quake in the fabric of reality. The role of dark matter. Though invisible, dark matter shapes the outcome of the collision. The halos of both galaxies are immense, overlapping long before their stars touch. These halos act like cosmic nets, capturing momentum and ensuring that the galaxies cannot escape one another. Without dark matter, the Milky Way and Andromeda might have passed by, each distorted but separate. With it, the merger is inevitable. Speculation deepens here. If dark matter sculpts the fate of galaxies, then the universe itself is guided by unseen hands. Our future, our sky, our place in the cosmos is written not by what we see, but by what remains hidden, creation through destruction. One of the strangest truths of cosmic collisions is that they are engines of creation. As gas clouds crash, they ignite starbursts, seeding the heavens with newborn suns. Entire generations of stars will be born in the chaos of the merger. Some may host new planets, new worlds, perhaps even new life. Thus, the collision of Milky Way and Andromeda is not only destruction, but genesis. It is the death of two galaxies and the birth of one. To call it catastrophe is to see only half the picture. To call it creation is to glimpse the larger truth. The universe is a cycle, and in every ending lies a beginning. The long silence beyond. But after creation comes decline. Once the gas is consumed, Milkomeda will quiet. Its star formation will dwindle. Its brilliance will fade. Over trillions of years, its stars will die, leaving white dwarfs, neutron stars, and black holes. And beyond lies a more chilling speculation. Dark energy, accelerating the expansion of the universe, will push all other galaxies beyond our cosmic horizon. From Milkomeda, the universe will appear empty. No spirals, no clusters, no cosmic web. The grand collision that created the new galaxy may also mark the beginning of cosmic isolation. Future astronomers, if any exist, may see only a lonely galaxy, unaware that the wider cosmos ever existed. Philosophical reflections. Speculation leads to reflection. If galaxies collide, if stars are scattered, if the sky itself is impermanent, what does this mean for humanity? The Milky Way and Andromeda remind us that nothing in the universe is eternal. Not stars, not galaxies, not even the cosmos as we know it. And yet, there is beauty in this impermanence. The coming collision is not a failure of stability, but an affirmation of change. It reveals a universe that is alive, dynamic, creative. It reminds us that destruction and creation are intertwined, that endings give rise to beginnings, that even in cosmic violence, there is meaning. Theories and speculations about the Milky Way-Andromeda collision are more than scientific models. They are windows into the nature of existence. They tell us that the universe is not static, but fluid, not eternal, but evolving. And they whisper the same truth Kepler once sensed. Beneath the chaos lies harmony, and within destruction lies creation. The birth of Milkomeda will be both an end and a beginning, both a shadow and a light. And though humanity may not live to see it, our story is bound to it, written into the destiny of galaxies, scientific tools, and ongoing testing, watching the future unfold. To speak of the Milky Way colliding with Andromeda is to speak of a future billions of years away. Yet modern science has already begun to witness the outlines of this destiny. Through telescopes orbiting Earth, satellites mapping the heavens, and supercomputers simulating cosmic evolution, humanity has found ways to peer into events that no eye will ever see. It is a triumph of imagination and precision, and a reminder that our instruments are extensions of the ancient gaze that once first noticed a faint smudge in the night sky. Hubble, measuring the approach. The first decisive evidence of Andromeda's motion came from the Hubble Space Telescope. By capturing ultra-precise images across decades, Hubble tracked the subtle shifts in Andromeda's stars, movements so faint they would be invisible without its sharp eyes. This revealed Andromeda's proper motion, the sideways drift across the sky, and confirmed what had long been suspected. The galaxy is not sliding harmlessly past, but heading directly for us. Hubble's measurements transformed speculation into certainty. The collision is not a possibility. It is written into the fabric of gravity, already unfolding in slow motion across millions of light years. Gaia, the atlas of stars. If Hubble revealed the motion of Andromeda, Gaia expanded the map to an unprecedented scale. Launched by the European Space Agency in 2013, Gaia is charting the positions and motions of more than 1 billion stars in the Milky Way. This stellar atlas allows astronomers to model our galaxy's gravitational field with extraordinary accuracy. By comparing the motions of Milky Way stars to those in Andromeda, Gaia refines predictions of how the two galaxies will collide. It reveals not only the broad outlines, but also the fine details, tidal streams, disrupted satellites, and the subtle tug of dark matter halos shaping the outcome. Gaia's data also shows us the scars of past collisions, stellar streams left by galaxies already absorbed. These serve as a rehearsal for the future, teaching us how stars move in mergers and hinting at what awaits when Andromeda arrives. James Webb, a new eye on Andromeda. The James Webb Space Telescope, though designed to peer into the earliest galaxies of the universe, also turns its infrared eyes toward Andromeda. By penetrating dust and revealing faint, cold structures, Webb maps the galaxy's hidden star-forming regions, its satellites, and its diffuse halo. This halo, stretching hundreds of thousands of light years, is the invisible boundary where Andromeda and the Milky Way already begin to overlap. Studying its faint stars and gas may reveal the earliest gravitational interactions between the two giants. Whispers of a collision, billions of years before the galaxies truly touch. Supercomputer simulations, rehearsing the collision. While telescopes observe the present, supercomputers simulate the future. By feeding precise measurements of Andromeda's mass, motion, and halo into gravitational models, astronomers create detailed. First approach. Andromeda looms in the sky, a spiral swelling to rival the moon. First pass. Galaxies tear through each other, stretching tidal tails of stars across the heavens. Oscillations. Drawn by gravity, they swing back, colliding again, each time losing energy. Final merger. The spirals collapse into one, forming a vast elliptical galaxy glowing with new star birth. Some simulations even trace the fate of the solar system, showing the sun hurled outward into a long, slow orbit on the galaxy's edge. Others suggest the sun may remain closer to the center. What all agree on is that the sky will be transformed. LIGO and the coming black hole merger. At the heart of both galaxies lie supermassive black holes. Their eventual merger will unleash gravitational waves of staggering intensity, rippling through space-time across the cosmos. While this lies far in the future, today's gravitational wave observatories, LIGO and Virgo, are already detecting smaller-scale mergers between black holes. Each detection is a rehearsal for the ultimate symphony, the collision of galactic hearts. By studying these waves now, scientists prepare to understand the signal that will one day echo from the birth of Milkomeda, mapping the invisible, dark matter, and dark energy. The most profound tools are those aimed at the unseen. Dark matter surveys map the invisible scaffolding of the galaxies, showing how their halos will guide the merger. Instruments, like the Vera Rubin Observatory, will scan the entire sky nightly, tracking the faintest motions of galaxies and their hidden mass. Meanwhile, missions like Euclid aim to unravel dark energy, the force driving the universe's expansion. Its role is, while dark matter binds Andromeda and the Milky Way together, dark energy ensures that beyond our local group, the rest of the cosmos drifts away. By the time Milkomeda forms, it may exist in isolation, its neighbors lost beyond reach. Artificial intelligence, reading the patterns. The flood of data from telescopes and surveys is too vast for human eyes alone. Artificial intelligence now combs these star maps, identifying structures, predicting motions, and simulating mergers at scales no human could calculate. In its own way, AI is continuing Kepler's legacy, searching for patterns hidden in the heavens, harmonies of motion too subtle for the naked mind, witnessing the unwitnessable. Through these tools, humanity does what once seemed impossible. We witness the unwitnessable. We map the motion of galaxies across millions of years. We simulate collisions that will not occur for billions. We listen to ripples in space-time from events long past and anticipate those yet to come. Andromeda's approach is slow beyond human experience, but through science, we bring it into view. The merger, which no eye will live to see, can already be imagined with clarity. In this, humanity transcends its limits. Though fragile and fleeting, we become witnesses to the grandest scales of existence. The instruments grow sharper, the models clearer, yet the mystery remains. We can chart the collision, but not its deeper meaning. We can predict the birth of Milkomeda, but not the significance of a universe where even galaxies must merge and die. For that, science gives way to philosophy, and the ghost of Andromeda's shadow falls not only across the sky, but across the human soul. Philosophical reflection / emotional close. Shadows across the human soul. High above the earth, on nights unspoiled by city lights, Andromeda can still be seen as a faint blur. To the casual eye, it is fragile, barely there. Yet hidden in that haze is an entire galaxy, hundreds of billions of suns, countless worlds, a spiral vast enough to swallow imagination. And across the gulf of time, it carries a shadow, the certainty that it's coming. For astronomers, this knowledge is precise, measurable, inevitable. For humanity, it is something deeper, a reminder that impermanence rules the cosmos, that even galaxies are not eternal. The Milky Way and Andromeda, two majestic spirals drifting through the void, are bound to meet. Their collision is not a choice, not a chance, but a destiny written into the laws of gravity, the fragility of permanence. For millennia, the night sky was humanity's symbol of eternity. Empires rose and fell, generations lived and died, yet the constellations endured. To farmers, sailors, poets, and kings, the stars were the one permanence in a fleeting world. But Andromeda's approach dissolves that certainty. The sky itself will not last. The constellations are temporary, fragile arrangements of stars caught in a brief alignment. The Milky Way's river of light will vanish, stretched into new shapes, dissolved in tidal streams. The night sky humanity has always known is as impermanent as a season, as transient as a breath. In this revelation lies a profound lesson. Permanence is an illusion, even on the grandest scales. Galaxies as living beings. To see Andromeda's approach is to realize that galaxies themselves are alive, not in the sense of breath or heartbeat, but in the sense of change. They are born, they grow, they collide, they transform. They are not eternal objects, but processes, vast rivers of matter and energy. When Andromeda merges with the Milky Way, it will not be a death, but a transformation. Two galaxies will dissolve into one, their spirals lost, but their stars preserved, their structures changed, but their essence enduring. Destruction and creation will be inseparable, two faces of the same act. In this way, galaxies mirror life itself. We, too, are processes, not permanent forms, born, changing, dissolving, transforming. The cosmos writes our story in its own. The loneliness of the future speculation carries us further. After the collision, the merged galaxy, Milkomeda, will shine brilliantly. New stars will be born. The night sky will blaze with unfamiliar constellations. But beyond it, the wider universe will fade. Dark energy, the mysterious force accelerating cosmic expansion, will drive other galaxies beyond our horizon. In trillions of years, the night sky will hold only Milkomeda, isolated in silence. Future civilizations, if any endure, may never know that the universe once teemed with galaxies, that a cosmic web stretched across the void. Their universe will appear small, confined, alone. In this haunting vision lies a paradox. We, fragile and early, live in a golden age of cosmology. We see the universe in its fullness before the shadows of time erase it from view. Andromeda's approach reminds us not only of what's to come, but of the privilege of now. Human meaning in cosmic change. But there is another way to see it. Though small, we are witnesses. Though fleeting, we have traced Andromeda's path, mapped its stars, and glimpsed its destiny. A species no larger than a flicker of dust has looked across millions of light years and foreseen the collision of giants. This act of comprehension, fragile as it is, imbues meaning into the void. Kepler, Hubble, Gaia, each generation has extended the star map, and in doing so, they have shown that the human story is not separate from the cosmos, but bound to it. We are participants in its cycles, reflections of its impermanence, echoes of its change, shadows across the soul. The title of Andromeda's approach is not only about the literal shadows cast by galaxies merging, but about the shadows cast across the human spirit. To know the future is to be humbled. To accept impermanence is to be changed. And yet, within those shadows lies beauty. If the stars above are not eternal, then their fleeting light becomes all the more precious. If the sky itself will change, then the sky we see tonight is unique, a moment never to return, a constellation never to repeat. Impermanence does not diminish meaning, it creates it. The final meditation. When the Milky Way and Andromeda finally collide, no human eyes may be left to see it. But the knowledge of it, the certainty of it, already shapes us. It teaches that the cosmos is alive with motion, that destruction and creation are bound together, that nothing, not even galaxies, endures forever. Andromeda's shadow falls across us not as doom, but as revelation. It tells us that permanence is a dream, that change is the law of the universe, and that within this law lies both terror and wonder. Perhaps this is the true gift of Andromeda's approach. Not the knowledge of what will happen billions of years from now, but the reminder of what is happening now. That we, fragile and fleeting, are part of this vast story. That our lives, our sky, our world are threads in a tapestry woven from impermanence. And so, when we look to the faint smudge above the northern horizon, we are not only gazing at another galaxy, we are gazing at destiny. We are gazing at the reminder that the universe is not still, but moving, that nothing is fixed, that all is becoming. And in that becoming, in that shadow across the stars, lies the most profound truth, that impermanence is not an end, but the essence of existence,